Okay, so for our simultaneous equations, 3 variables, the first thing we do is we always label our different equations A, B, and C. Okay, just A, B, and C, so we remember which one is which. The second thing is then to usually look at which variable I'm going to try and cancel, whether I'm going to try and get rid of the x's, the y's, or the z's. The situation here is that C looks absolutely bizarre. Okay, I'm not used to solving simultaneous equations with fractions in them. Okay, luckily, I know that in simultaneous equations, I can decide to multiply across a full line. Actually, I can do it in any equation, not just simultaneous equations. I can multiply across a full line by something to get rid of the fact that there is fractions in this. Okay, so what's the smallest thing I could multiply by to get rid of denominators of 4, denominators of 3, get rid of halves? Okay, the smallest thing I could multiply by there is 12. Okay, so I'm going to start by rewriting out my equations, okay, and getting rid of the fractions in C so that I can look at this as a normal simultaneous equations question. Okay, so A and B are going to stay the exact same. And then in C, I'm going to do out a multiplication. Okay, so so the way I'm writing out A, B, and C to label my equations, you should do the same thing. And then the other thing that I'm going to do as I go through this is try and have all the x's one on top of the other, the y's one on top of the other, the z's one on top of the other. So because I don't have a number in front of the z here, I can leave a gap because I know that the others are going to have numbers in front of the z's, or I could write in 1z if I wanted. Okay, and that is equal to 1. Now, if you don't leave a gap, look, it's not the end of the world. I'm just doing it like that so that they kind of fit in really nicely, one on top of the other. So here, the way I have minus 3z. Okay, and then lastly, this line has to be multiplied by 12. So 12 over 4 is 3. So I'm going to have 3x plus 8y plus 12z. So here I'm kind of going to have to squish in the 12 so that it's in that same space that the others were. Okay, and that's equal to 66. Okay. So there are my equations that I can use. Okay, I can essentially just treat them like my original equations. Which variable looks easiest for me to get rid of? I'm probably going to look at the x's, getting rid of the x's here first, because if I look at A and C together, they've already got the x's with the same numbers in front. And then if I look at B with either A or with C, I can just multiply B across by 3 and also have it the same number in front of the x. Okay, so I'll probably look at getting rid of the x's. I could have looked at other ones as well. Okay, the y's might be slightly complicated. A and C together, you can get rid of the y's easy enough. But if I was looking at B with one of them too, it would end up that I have to multiply out both lines. It will still work out perfectly correct. Z's could also work very nicely as well, just not as nicely as the x's are in this case. Okay, so I'm going to focus first on getting rid of the x's in this one. Okay, so I'm going to look at A with C first. Okay, so every time I'm writing down what equations I'm using, 1 for myself to track and 2 for the examiner to be able to track. Remember, you want it to be easy for them to see where they can give you marks. Okay, remember as well, at this point, when I write them down, I'm not changing anything in this one step. But in my next step, I can make some changes. Now, you guys said that you actually prefer when, instead of having to recognise when to add both lines or subtract one line from the other, you actually prefer to just get different signs on one of the lines. Okay, so if that's the case, if you're happy at this point to be like, oh, I need to subtract one line from the other, absolutely do that. If not, just simply multiply across one of your lines by -1, either of them. Okay, and we'll get, so again, I'm going to have A and C. Okay, I know I'm slightly changing A, but it is still the equivalent to A. Okay, it's still the equivalent equation because I haven't tried to merge it with another equation or anything like that. Okay, so I'm just going to get minus 3x minus 4y minus z is equal to minus 1. And then c, we haven't changed anything about it. Okay, and now at this stage, I can just add both lines. Okay, so I'm going to add both lines. So that my x's, I have minus 3x plus 3x goes to 0x. Okay, if you want to write that in, you can. Honestly, it's just 0x, so I wouldn't bother writing it down. And then we have minus 4y plus 8y is going to give me 4y. Minus z plus 12z is going to give me plus 11z. And then that's equal to 65. Okay, that is no longer equation A or equation C. It's a new equation because I've merged two equations together. So I'm going to give that a new letter. Okay, let's call that letter D. Okay, because we've already used A, B, and C. Okay, so now we have one new equation. Okay, I can continue working downwards here and try and get another new equation. Okay, now the way I use simultaneous equations, remember, I need my next equation to also have these same variables. So when I'm forming my next equation, I need two equations that are both in y and z. Okay, so y and z have to be the two variables I'm left with when I get my new equation. Okay, it doesn't matter which of these ones up here I use. I've already used A and C together. So if I try and use A and C together again, I'll just form this exact same equation again. So not A and C, but I could use A and B together, or I could use B and C together. Okay, so either of those. I'm going to go and use A and B together, just because I feel like when you guys sit down and do this, it might be more likely that those are the ones that you've chosen. Okay, but if you used B and C together, you should still end up with the same answer at the end. Okay, so I'm rewriting them out. Yes, I can see them above, but I want to just focus on those two equations without C. So I'm rewriting them without C involved. Okay, now at this point, I need to get rid of the same variable I got rid of up here. So I have to get rid of the x's. Okay, so I can't choose now, oh, it looks kind of easy to get rid of the z's. I can't do that because I've already started by getting rid of the x's. So unless I want to restart the question and get rid of the z's, okay, unless I want to do that, I can't go and change what I'm getting rid of now. Okay, so I've already started the question getting rid of the x's. So here I'm going to get rid of the x's again. Okay, so get rid of the x's again. How could we do it? Okay, multiply across b by a minus 3. Okay, so a is going to stay the same. B, we're going to be writing down an equivalent equation. Okay, so I can still call it b. So I'm going to have 3x plus 4y plus z equals 1 for a. And then for b, I'm going to have minus 3x plus 15y plus 9z is equal to plus 12. Okay. So now I'm going to merge them equations together. Okay, so I'm going to add them together. And I know that the x's are going to cancel. Okay, so it's going to be 3x minus 3x, so 0x, so I don't need to write it. And then I'm going to end up with 19y plus 10z is equal to 13. Okay, so that is my new equation. Okay, I have now formed a second equation and it is in just y and z. Now look at what we have. We have two equations with two unknowns. That's junior cert, simultaneous equations. Okay, so let's bring them together. So D and E, bring them together and solve them as if those were the ones you were given at the very start. Okay, so let's bring them together. So we have 4y plus 11z is equal to 65. and I have 19y plus 10z is equal to 13. Okay, neither of those variables are nice to cancel out. So it's quite mean. Okay, 19 by 2 is 38, so 4 won't go in. Okay, so I'm actually going to have to multiply, if I want to cancel the y's, I have to multiply the top line by 19 and the bottom line by 4. Likewise, if I want to cancel the z's, I'm going to have to get them to 110, so I have to multiply the top line by 10 and the bottom line by 11. So it's really up to you. They're as difficult as each other. So I'm just going to go and multiply by, I'm going to get rid of the z's first, because I just think it'd be easier to have to multiply across by 10 and 11. They're kind of easier numbers to work with than 19. Okay, so I'm going to get rid of the z's, so I'm going to get 110z in each spot. Okay, so that means that I'm going to have 40y for d, so I should have labelled that, so that's the equivalent equation for d, and then e. Okay, so 40y plus 110z is equal to 650. Okay, and then 19 by 11 is 209 y plus, oh sorry, that's the other thing. I should have recognised I wanted 1 to be plus and 1 to be minus. Okay, so I could multiply here all these by a minus 11 instead. Okay, so then it's minus 109. Sorry, minus 209 minus 110z is equal to, and then minus 143. Okay, so let's add both lines together so that we get 209 minus 40. Okay, so we're going to get minus 169y. Okay, the z's will cancel, they'll go to 0, is equal to, and then 650 minus 143 is 507. Okay, so 507 is 169 y's, or minus 169 y's. Okay, so to get y by itself, I'm going to divide there by minus 169. So that means I have to divide it over here by minus 169. Okay, and I'll be left with y by itself, and that's equal to minus 3. Okay, so think back from here downwards, we've been working junior cert simultaneous equations. Okay, in junior cert simultaneous equations, what else would you do after this? You'd put it back into one of my original, okay, I'm doing my speech marks, my original equations, from here to get the other variable. So choose whichever one of these looks like the easier original equation, okay, to put y back into. I think probably D is the slightly easier one. Okay, now I've run out of space, so I'm going to put a clear mark down my page because I haven't gone into the second half of this, so I can do that. Okay, if my writing went really far across my page, I'd have to write in go to spare paper, and on the spare paper in the back do write in its question, whatever question this is, 3b continued. Okay, so right, so I'm going to put it back into one of my original equations. So I'm going to choose equation D. So I'm going to write down the original equation I'm using. Okay, and equation D is 4y plus 11z is equal to 65. Okay, so I'm going to put into that y is minus 3. Okay, so that's 4 by minus 3 plus 11z is 65. Okay, so that's minus 12 plus 11z is 65. Okay, so we're just working to get z on the side by itself here. Okay, so we're going to get 11z is 65 plus 12, so 77. Okay, and then divide both sides by 11 to get that z is 7. Okay, so now I've found 2 of my unknowns. I have y and I have z. So now at this point, I go back to one of my actual original equations. So these ones in green. Okay, now I've already messed with c, so it's not as safe to put it back into c. Okay, it's a lot safer to maybe use a or b. So choose which ones you're going to put it back into. Okay, I'm going to put it back into b. Completely up to you. Okay, so b. So that was x minus 5y minus 3z is equal to minus 4. Okay, so I have x, I don't know, minus 5 by y, so by minus 3, minus 3 by z, so by 7, is minus 4. Okay, so just work out there for x. So x plus 15 minus 21 is minus 4. So x minus 6 is minus 4. So add 6 to both sides so that we get that x is 2. Okay, if I wanted to verify, only if I have time, okay, I can get a different colour pen, make it very clear what my final answers are. So y, z, x. If I wanted to be really nice actually finishing this question, I could, at the very end, actually put in my point. So x, y, z. So 2 minus 3, 7. Okay, but I'm going to get my different colour pen. I'm going to write in that I am verifying. And if I want to verify, okay, I'm going to make it really, really super clear that I am verifying. And I'm going to use one of my original equations that is not b. Okay, so not the one you used in the last step. So I could sub back into a or back into c to verify my answers. Okay, so if I wanted to verify, I could sub back into one of my other original equations that I didn't use in the last step. Okay, so 3x plus 4y plus z is equal to 1. So that's 3 by 2 plus 4 by minus 3 plus 7 is 1. So if both sides work out the same, that's me really, really happy with my answer. Equals 1. So if I simplify that left-hand side, it's 1. So 1 is equal to 1. So I'm happy. Okay.